Hello all, welcome to Tech Recess. In this video, we will discuss about designing a key value store, which is a very popular interview questions basically asked from developers who are a bit experienced and senior in their role, and also from architects, right? So let's understand the key value store designing. So key value store is utilized in situations when you have requirement to access data very frequently, right? Because reading from database is very costly affair because of the high IO operation cost. So the data which is frequently used, we put in the key value store. So kind of a caching mechanism, right? So for example, companies like Amazon, Google, Facebook, they have billions of users, and it's not possible to read write directly from the database for each operation. So key value store comes in a very handy way, right? So to understand key value store, it is having two things, right? So key and value. So key is something which is unique for a key value store, and the key can take the value of integer, string, but also you can utilize the hash tables, and you can generate key using the hash functions as well. But value can be taken as anything, maybe integer, decimals, or strings, or maybe blobs, images, and it depends upon your requirement as well. So, in a nutshell, we can say that key value store is a design where key is a unique and value can be taken as per the requirement, right? So, design the key value store, you have to make sure three things, right? The reliability, scalability, and availability. Because we are trying to design an application which is going to cater the millions of users. So we have to think about these three terms in a very serious manner, right? So let's see the how do you respond to this question? How do you start, right? So the first step to start the solve this question is that you have to define the requirements, right? And requirement will be come into two flavors. One is the requirement which are functional, and another is non-functional requirement. So mostly there's a mistake done by the uh, responders, right? So that they focus on the functional part and leave the non-functional part. So it gives very negative impact onto the interviewer, right? So let's see the for a particular case when we are trying to design a key value store, what are various requirements which are functional? So, for example, so first requirement is here that we are able to read and write from key value store, right? So, this is the most important requirement of a key value store, that we are able to read and write from the key value store, right? Second requirement is configurable. So maybe requirement is like you can configure the values to different data types and other things, right? So you can configure the your application in such a manner that you can tweak it as per the requirements. Okay. Then third thing is that whatever the hardware you are using, it should be independent upon your application. So maybe there should not be any dependency on the hardware as such, right? So your app can run into the any server, maybe Linux or Windows, whatever, right? So these are three functional requirements, and also sometimes we have servers or different makes. So that also, so it means that whatever the application you are writing should be not be having any aspects which are linked from the hardware, right? So it should be hardware independent. Then the functional requirement are covered. So requirements which are non-functional are basically scalability. So scalable, right? So it means that because initially maybe you are designing your application for maybe 1 million users, right? But in future, you might need to cater to the more bigger number, right? So for that, there should be way to scale your application. So that is also a very important aspect. Third thing is that availability, because Normally, key value store is on top of the database, so we want to be highly available. For example, suppose you have application which is like which shows their balances, right? The like customer balances of their money in the bank, right? So suppose your backend is down, but still you can show some data to the customer so that they're able to see their balances at least, right? So uh, in that case, you make sure that whatever the key value store design is there should be highly available. And third thing is fault tolerance. So whatever we try to, at whatever extent we try to make our design robust, but there will be some fault happening, right? So maybe the fault will be temporary, maybe because of the power failure, or maybe some cooling issues in the server. But how do we make sure that there is no permanent problem happening to data? It remains consistent, right? So how can we be more fault tolerant in case of the temporary failures, right? So first step for the interview, you have to ask the questions from the interviewer and clarify all your doubts and also define the requirements, both the functional and non-functional. So that is the first step you have to do. Then you have to start one by one on each of the requirements. So let's start from the designing of the API. So it's very simple, right? So API design is having just, I mean, at higher level, it is having the two functions, two API exposed. One is the get key. So user is having a key and they want the corresponding value to be fetched from the key value store. So we have to design one function called get function that takes the value, that takes the key as an input and gives back a response as a value. And then second is like to write the data into the key value store. So we have to use the put function, and then it requires the key and value. So whatever the key and the value, but make sure that whatever key you are designing that should be unique, because otherwise, if you are trying to reuse the keys, it's going to be overriding your data which is already present in the system. So that's the API design we have seen. So now let's see the other aspect. So the configurability and the hardware approach, hardware heterogeneity, those two things will be already part of your design, right? So you'll make sure that there is no function utilized in your code that is dependent on the hardware, and also your design is very configurable in such a manner that values can be anything which can be configured. All those aspects you have taken care. So the functional requirements are not that complex for this application. So now let's focus on the requirements which are non-functional. First is the scalability, right? So scalability means suppose you had developed your application and deployed to one server, but later you want to cater to the more users, so you have to add more and more servers, right? So once you add more servers, so how do you make sure that all the servers have the proper keys distributed, right? Suppose here in this example, you can see that you have four nodes, right? 0, 1, 2, and 3. So what we do, so whenever any request comes, right? So for that request, we do a hash function on that request and find a value. Then we get the node number. For example, the request ID is 1 in this example, and we got the hash value as 10. Then we do a mod of 4. Why 4? Because we have 4 nodes. So the value of mod 10 mod 4 is 2. So that request going to store in the node 2, right? So now it's all good. We are fine. We have scaled our application, and there's no issue. But the issue comes when server is unavailable, or you want to remove a server, or you want to add a new server, right? Because you don't know that you will need these four servers, or might need two servers in downtime. Maybe you need 10 servers, right? So with this approach, what happens that you once you apply this approach, right? Hashing the request ID and getting the so that the server number. So suppose you remove one server, right? So the hash number becomes 10% 3, right? So in that case, all the keys in the system will be affected. So there will be huge reshuffling of keys. So maybe if you reduce the server or add new server, there will be a lot of churning happening among the keys, and they will be transferred from one to another node. So it's a very difficult to scale, right? So because adding or removing node is very costly here, because whenever you are trying to add or remove a node, you have to shuffle the keys, right? So at a lower level, this approach is not bad. You can do that, but the best approach to scale is the consistent hashing. So this topic, this hashing technique, I discussed in my videos already, but I'll explain again in this context. So suppose, so in this consistent hashing, what we do, we define a logical ring structure. So here you can see that you have four servers, right? S0, S1, S2, and S3. So now the responsibility of S0 is the keys, which range from S0 to S1 only. So, and similarly, the responsibilities of keys for S1 is S1 to S2. So all they look forward, they look ahead, right? So for example, we have 100, right? So 100 in between the S1 and S2. So all these key will be served by the S1, right? So that's how we define. So let's see. So you can see here, right? I have put 44 and also 52 for S naught to S0 to serves, and similarly we have another. So this ring is showing all the request ranges which they are serving, right? So this is serving S naught is serving till 90. After 90, it is served by S1 like that. So now in this case, suppose you want to add a new server, suppose, right? So now S5 has come between S0 and S0 and S1, right? So here so only impact is going for S0. There is no impact for S1, S2, or S3. So what will happen? Now S0 will give its share to the S5. So now S5 will take some keys from S0 like this, and it will cater. So only the key churning or key movement happening from S0 and S5. All other servers are not affected. Similarly, if you want to do a removal of a server, right? For example, you remove the server S1, yes. So now all the keys which were served by the S1 will be taken care by the S0. So now S3 and S2 are not impacted by this. So by this change, right? So scaling while doing the consistent hashing is very efficient manner. So that's why this is a scalability approach we normally take, right? So you should also apply this scalability approach in the key value store. So whenever you have the multiple nodes to be used for scaling, we can utilize this approach, right? So one requirement which is we have covered. So now let's see a next requirement, right? That was the availability. So for that, what we do? So suppose any node can go down, right? So how do we make sure that even if the node has gone down, we are available? So for that, there is one approach in which we use the primary secondary approach. That means that we have one server that is used as a primary server that takes all the writes. So all the writes are happening to this primary server, and this primary server is going to duplicate that data into all the secondary servers. So the read is happening from secondary servers, but write is happening only on the primary server, right? So in this approach, what happens that there is a single point of failure, right? So suppose all writes are happening with the primary, and in case primary goes down, the system is they don't know like what data it was written already by primary, but not sync with the secondary. So this approach is also fine for the lower volume application, but because it is having a single point of failure, so let's not focus on that. Let's see the other approach for replication of data, that is the peer-to-peer approach. So in this write, what happens that all the nodes take the read and write, but they also make sure that asynchronously they sync up data with another node. So for example, this server right here, so this got some writes, but it will also make sure that it will propagate that data to this other peers also. So it means that in this approach, all the nodes are taking the read and writes, but they also make sure asynchronously that they sync up data with each other. So this is also a very good approach for the highly available system, because in case something goes down, there'll be some problem, right, for those reads which are like in transit, but writes also the in transit, but normally it will be taken care by the other, because the servers, because there will be not a single point of failure for this particular approach. So let's see, let's understand this by one example. For example, here we have these six nodes A, B, C, D, E, F, and we want to utilize the peer-to-peer approach, right? So what we do, we define like this, right? Suppose A is serving the key, right? I mean the B serving the K key, right? So now it will write into the B, but also replicate to other servers also. Like for example, here we have a factor of 3 for replication. So we will make sure that it also having data, also it send data to C and D. So, so basically what we do, we define the replication factor that data will be replicated in how many servers, and then for those keys, it also sync up with another node. For example, we see here, right, in the node C. So node C is possessing the key L and also propagating it to the node D and node E. So that's how we are doing replication, so that we build system which is highly available, right? So that's how so we can define this factor as for our requirement. So that's how we make sure that data is sync up with the node, and also we are able to be highly available system. Now the last requirement for the non-functional part was the fault tolerance, right? So for the fault tolerance, if the fault is temporary, right? So in the case of a temporary fault, so what we can use the concept called hinted handoff. So here what we do, we prepare a preference list like this. Here you can see that list is A, D, C, B, G, and E. So for example, during the operation of this application, node A goes down for maybe few seconds, right? So now any request coming to node A will be sent to the server D, because the preference list, if A goes down, the D will serve this. So there will be hint to the server D that okay, this request was intended for the server A, but because server A is temporarily unavailable, please process that. But D will be knowing, okay, this request, although I am processing it, but it was for the node A. So once node A backs up, it will send data back to the node A. So it will both will sync up. So this is also a very good approach in case of there are very temporary failures. But for the failures which are like more lasting, or you can say they are like permanent failures, so that we have to use the replication of data so that we can take a backup. Also, sometime when system goes down temporarily for some time, there will be multiple copies of data, right? So there will be multiple versions of particular data. So how to resolve that data which are like present for one particular key? How can we resolve that? Which one to take up to write, right, and which to discard? So for that, we can use timestamps. Uh, Timestamps mean like what was the latest insertion or what was the latest data available, so that we can also basically take that version and update our nodes. But sometime in system which is distributed, the clocks are not like in sync up, right? Maybe one server is in India, one server in US. So maybe clock will not be giving perfect timestamp. In that case, we use the vector clocks. Okay, so vector clocks is also utilized so that we know, okay, in case of multiple versions of data, which one to choose. So I will cover that vector clock concept maybe in my next videos. But for now, this is the approach to design a key value store, and I hope this will give a good idea how to handle this type of questions in the interview. So focus should be both on functional and non-functional requirements, and because functional grammar is very easy, right? Only key value pair we define, that's it, get and put functions. But the main thing is that the main thinking goes where you want to make sure system is highly scalable, available, and fault tolerant. That is the area where you have to focus and show your skills to interviewer so that you get a good job offer. Okay. So yeah, thank you very much for watching. See you next time. Please leave comments or questions